In this equilibrium question, we're asked to consider the equilibrium constant with respect to pressure, Kp. It's calculated almost the exact same way as the regular equilibrium constant with respect to pressure. The only difference is we're substituting pressures instead of concentrations. Also, the equilibrium constant with respect to pressure can only be used for gases, of course, because solids and liquids and aqueous species don't have pressures. So we would just take note of the equation. Product pressures will be raised to the power of their coefficients, just like we would in an equilibrium expression with respect to pressure. So for instance, because of this coefficient 2 for NH3, we get an exponent 2 in the expression for the equilibrium constant. There's an implied coefficient of 1 for nitrogen in the equation, and so an implied exponent of 1 for the pressure in the equilibrium expression. And lastly, because of the coefficient 3, we have an exponent of 3 for the pressure of hydrogen. The reason this can work out for gases is because pressure serves as a proxy, or something that can take the place of the number of moles, which would then also be moles per liter if we're talking about the same container. So also pressure, molarity. So we just plug in the values that they gave us. For NH3 it was 3.1 times 10 to the negative second. For N2 it was 8.5 times 10 to the negative first. And for H2 it was 3.1 times 10 to the negative third. It's just a matter of crunching numbers at this point. And if we plug into our calculator and solve, I get 37,950, which, since those pressures were given to us to two significant figures, we should answer to two significant figures. So 38,000 is our value for Kp.